Mr. Nooms, what's glycolysis?
Jimmy, I'm glad you asked. Glycolysis. It's the breakdown of glucose. You're breaking glucose down into two pyruvic acid molecules. You see, the first step, that C6 molecule representing glucose gains a phosphate group. Where does it get that phosphate group? It gets it from ATP. ATP breaks down, and that breakdown couples to that C6 molecule. So ATP gives off energy and it gives its phosphate group. The same exact step repeats. We end up with a glucose with two phosphates attached. Now, truth be told, I'm skipping a few steps. But these are the two key things that help us count the number of ATP used and the number of ATP made when this is all said and done. As soon as we've made that C6 molecule with two phosphate groups is going to split. It's going to split into two molecules with C3 with a P. See how C6 split into two with C3? Two P's, each one has a P. Are you with me? Good. Now, as soon as that's made, by the way, those molecules, the C3 with the P is called P-gal, phosphoglyceraldehyde. We are going to give that phosphate right back to an ADP to form an ATP. And the molecule C3 with a P becomes a molecule without the P, a C3. They have names. We don't need to know them. That C3 then goes through another reaction. I'm going to color that yellow just to show you it's a different C3 molecule than the previous one. This time, it gains some electrons, or it gives away some electrons that are given to a hydrogen ion and a molecule called NADH. Sorry, NAD+. And it makes a molecule called NADH. NADH is an electron carrier. It's going to carry those electrons somewhere. You'll find out when we talk about respiration. That C3 is then going to turn into another C3. I'll shade that in green so you get the idea that it is yet another C3 molecule. Has 3 carbons, has a different arrangement of the oxygen and hydrogen attached to it. Now, when this happens, we make another ATP molecule. This time, however, the phosphate comes from a free inorganic phosphate, represented by the Pi. Now, the same exact thing happened to the other P-gal molecule. So I'm going to speed this up, show you the exact same thing that happened. And ta-da, we end up with 2 pyruvic acid molecules being made. Oops, let me fix that. That's better. Green and yellow, just to make which one is analogous to each side, etc. Now, all said and done, what's the net production of glycolysis? We're going to make a net of 2 ATP because we used 2 ATP to start, and then we made 2 ATP.
Don't you mean 4 ATP are made?
Yeah, that's right, Jimmy. Quiet down. We also made 2 NADH down here in the second part of glycolysis on both sides. If you are curious what happens to pyruvic acid, check out aerobic respiration video.